By the 1930s, Yellowstone's last wolf was dead. In the 1800s, we entered this realm which wolves had ruled as top predators for millennia. We sized them up as a threat. Between 1883 and 1917, more than 100,000 wolves were killed for bounty in Montana and Wyoming alone. By the 1970s, they were listed as endangered in the US. Biologist Doug Smith has studied wolves for most of his life. He sees the amazing possibility that their absence could somehow be connected to Yellowstone's missing forests and eroding riverbanks.
This animal, wolves, was a part of North American ecosystems. And a big question for biologists worldwide is what has been the effect of removing large carnivores.
An experiment that began in 1995 for a completely different purpose could help to answer this question.
8 Canadian gray wolves were locked in small metal cages, prisoners despite overwhelming nationwide.
In an intensely controversial act of wildlife management, Doug Smith and colleagues brought 31 gray wolves from Canada to Yellowstone. What grabbed the headlines was the politics of predators. But their effect on the environment would become the more enduring story. Research suggests that the elimination of Yellowstone's wolves allowed the elk to browse aspens and willows brazenly. Though other factors may have played a role, it seems the disappearance of trees and streamside vegetation can be traced to the missing wolves. Now, where elk are on the run, trees and shrubs are starting to come back. And other species appear to be benefiting as well.
And when I first did the beaver survey for Yellowstone in 1996, there were no beaver colonies in this whole area. And this colony has just come in and they've settled right here. First colony in Lamar Valley probably in decades.
Once again, willows are offering beavers the materials they need to construct their dams. In turn, beaver ponds offer extra water and a buildup of nutrients, so plants can flourish on the banks as they did more than 70 years ago.
By putting back one thing, we're restoring a whole bunch of things. An entire system, really, and how that system works. And so that should give people who may never see a wolf a strong feeling of hope.
In its heyday, Discovery Bay, like most of the Caribbean, is teeming with life. At the top of the food web is a gamut of predators. Sharks, snappers, groupers, and jacks cruise near shore to feed. They are drawn by a tempting menu living on the reef. Surgeonfish, parrotfish, and other herbivores that graze algae growing on the coral. But this Discovery Bay lives only in photographs. All that's left to remind us of how vibrant this reef once was. Today, the hunting grounds of the big fish, the coral reefs, are dying, suffocating under a shaggy layer of algae. The prey fish, the herbivores, are vital to reefs. Their grazing helps keep fast-growing algae in check. As fishermen removed them, only one significant grazer remained: the spiny urchin, which soon succumbed to a disease. And now the fished-out reef could no longer resist a devastating outbreak of algae. A cornucopia of chemicals enters our homes, and not only through tap water. Hundreds, if not thousands, of man-made chemicals are found in the food we eat. In our carpets, fabrics, and detergents. In our cosmetics. Through our plumbing, these compounds flow out into the world. And that's where they can affect lives beyond our own. Mercury from industry seeps into the lake. At the bottom of the food chain, bacteria can transform this mercury into a highly toxic form called methylmercury. As tiny organisms feed, they take in the methylmercury of their prey. The next predator gets a more concentrated serving, and so on up the food chain. The mercury concentration in top predators can be over 10 million times greater than in the water. Meager is a pioneer in a new scientific field that uses plants to clean up environmental messes. Some plants have a natural ability for handling toxins. Ferns can survive in arsenic-laced soil. Alpine herbs in zinc. Mustard plants in lead. Clovers in motor oil. But Meager knew of no plants that can withstand large amounts of methylmercury. He was, however, aware of bacteria that process mercury. Could he bestow this talent on plants? Adding bacterial genes to plants was a simple idea, but its execution, and persuading the skeptics, took years. But Meager persevered. After 2 decades of trial and error, he succeeded in getting mercury-eating genes into plants. One of his plants stores mercury in its leaves. Another emits it in less harmful form as vapor. If Meager's technology is adopted, large amounts of a toxin will never have the chance to enter the water. Mercury is only Meager's first target. Other poisons are already in his sights, as are the bacterial genes that will become part of his next arsenal.
So for me, we just started. I've got hundreds of genes in mind. We've got maybe 20 we've worked on already. We're having a very high success rate. I think you're seeing the birth of a new field. There's no reason that the environment can't be 10 times cleaner.
According to one school of thought, toxins are diluted to safe levels by the time they reach the open ocean. But are the creatures that live here really protected from chemicals? In the past decades, researchers have become aware that sharks, bluefin tuna, swordfish, and killer whales all have toxins in their tissues. Water's path may twist and turn, but the destination is always the same: the ocean. Rivers spill off the shores, creeks flow into rivers, and marshes and ponds feed the creeks. Relying on this liquid network are creatures large and small. By listening to these animals, we can hear messages about our water, our health, and the health of our planet.